think I'll just kick off by saying I was just glad to be able to join, but I wasn't able to do much work over the week as I shifted uh, location. So I saw Steve had posted something, and if anybody else also would like to share, but since I saw Steve's posting, I'll yield the floor to him. Steve, you want to share and take us through what you were able to do, and I'm eager to see what results you got as well.
Yeah, sure, yeah. Really, it was only down to the fact that, yeah, like I found out, like Jovian, where you can sort of record your experiment results.
Yeah,
It never,
actually, sorry, Steve. Since several people may or may not have used, I think the guy for those who did the previous competitions are familiar, but maybe you want to tell the rest of the guys what Jovian is, and then take us through your use in this case, use of Jovian in this case.
yes, I'll share my screen here if it works, if my Wi-Fi handles it. Can you see that?
Yep.
Yeah, so Jovian basically is a place where you can send your experiments to, and you can have like different experiments. And yeah, so here, this is just like a notebook I've created. It's like basically based on Gautam's notebook. So all it's doing is exactly the same as what he did using the universal sentence encoder, except rather than just doing like the cosine similarity of the encoding vectors, I've just stuck them into a binary classifier. So with Jovian, it never used to work with Google Colab, whereas now they've fixed it. So what happens is when you actually run your notebook, at the very end of the notebook, you can just put this commit line in, and it'll send your whole notebook over to Jovian, and it also sends with it the hyperparameters that you used in your notebook. Additionally, because this competition is sort of a public Kaggle competition, you can send your notebook. You can create the submission, and you can send it in automatically into Kaggle, and then you can get the results back. And so with that, then you can use those as parameters also in Jovian. So here it runs a notebook in my case. Yeah, so it's just doing like a classification between the two embeddings to see if they're duplicates or not. And then it gets the result back and like logs it. So this is the whole notebook that's come back into Jovian. And then if you look up at the top here, you can have a version. So within this, so you can see here, I've like submitted 4 different ones, and these are the scores that have come back out of the Kaggle submission. And these are the other parameters that the notebook has recorded. So it's a good way to sort of keep track of how you're getting on, and because like half the time I sort of change one thing and then forget what I've changed, whereas here it records the whole thing. And you can see like the scores like gradually get a little bit better and then get worse again. So I can see that going up to 60 epochs is sort of taking it too far. So yeah, like in the past on various competitions, I've found this to be good and like a good way to keep track of everything that's going on. So this notebook here, I shared it, so like it's all public now, so anybody that wants to go in can see that.
Great, thanks, Steve. I think so. What besides the learning rate, did you change anything? I mean, of course, the epochs, but besides that, anything between the 3?
No, so as I say, it's just like a very, very, very simple notebook. So all the rest of it's the same as Gautam's. So this chart here, it's like from the sort of the main universal sentence encoder thing where it shows the similarity between the sentences. And I've added like these last 2 sentences in. So you can see if you have a sentence like so when sentence and a where sentence, it like says that the two of them, this is the cosine similarity. So it says, yeah, like the two are really, really similar. Like obviously from Core's point of view and somebody asking a question, these questions are completely different. So what I've done here is, so just got the embeddings for everything, and then like just stuck them in, like the two separate inputs, one for each sentence for the embedding for each sentence, and then just like train them to say, or using the duplicate column to say if they're duplicates or not. One thing about this approach is this is using Keras. Keras actually has a specific universal sentence encoding layer that you can use, where instead of putting in the encoding vector, you can actually put in the sentence itself, and it'll go off and get the embedding, and then it actually lets you sort of fine tune the embedding, which would probably give you better results. But I tried that, and it's very, very slow because of the fact it's like converting each sentence on the fly to like an embedding. Whereas here, because it's like done it all up front, it's a lot faster. But yeah, so the only thing I've messed about with is this learning rate. But as I say, it was more just a sort of experiment to see if Jovian would work okay.
Yeah, the whole setup at least you have so that you can experiment with various things quickly.
Yeah.
And keep track, more importantly.
Yeah, and as I say, the good thing about this is like for anybody who wants to see, it shows you exactly how you can use Jovian and how you can use the automatic the submissions in the Kaggle, like just by like using these two lines. So you don't have to save your submission file and go into Kaggle and upload it to get your results. You can just save it on your like Google Colab notebook and submit it directly and get the results back.
Yeah.
So yeah, so for anybody who wants to see it's up and like, then they can sort of expand on that.
Sorry, one more question. You mentioned, so currently you're using the sentence encoder from Google that Gautam had used as well, right? That inherently gives you a 512 wide encoding.
That's right. Yep.
Okay, and then you were saying Keras has a sentence encoding capability built in that you.
Yes. Yeah. So here I've used the universal sentence encoder. So the sentence goes in here, and this returns me the encoding vector.
Right.
And then I put the encoding vectors in just here into the very simple model. But what you can do is, rather than putting in the vector as an input, you can put the sentence in as an input, and then Keras has like a map universal sentence encoder layer, it's called. So you would put the sentence in, and then Keras would automatically do like this bit here on the fly. So it would take the sentence and then convert that into the vector. And if you do that, then it lets you fine tune the vector. Whereas like here, these vectors are static now, like they're not being changed
They're
at all.
embedding, right? So when you
Yep.
say provide the sentence, so do you don't do any encoding, just a string. So you provide strings basically.
Exactly. Yeah. Yeah. So like here, so when I'm training this network, here I'm using the embeddings. So like it's automatic. Yeah. I've pre-processed all the sentences and turned them all into embeddings. And so like in the model fit, X1 train here is the vector for the first sentence. That's the second question, but those are the embeddings. Whereas if you use the Keras specific layer, you can just directly put the string in, the sentence string, as the training values. But as I said, it was very slow to do that.
I see.
So like, especially when it came to the testing bit where you've got however many it is, like sort of a million. Yeah, like it took forever. So I got fed up waiting for it and just made the embeddings up front.
Interesting. Yeah, what's interesting though is with this approach too, it seems like I was actually thinking you would see. I mean, you haven't played too much with the network itself, but um, I thought you we would see better results than actually. Sorry, your score was point three something,
Yeah.
0.39.
Yeah. Yeah. So it is actually better, I think, than.
Oh, it's
Oh
definitely
yeah. So
better than
here.
the previous things, but then
Yeah. Yeah.
yeah,
So this
direct,
one here,
right?
that score there, the 0.95, that was from using the cosine
Right,
similarity.
right.
Whereas, yeah, like these ones above, these are all from the classifier. But yeah, in terms of like, yeah, like the leaderboard, it's 0.11. So
Yeah, exactly.
yeah,
That's
like I'm
the thing.
still,
I
yes,
think
miles
if I
off that.
recall, the top 10% is somewhere in the 0.15 range. If I recall, I could be wrong, but somewhere in that. So and because I would have thought that the sentence encoder using, because it is from Google. I haven't looked at it in detail. Maybe Gautam can, if he has spent some time on it, educate us. But I would have thought it would have used, all the transformer and all these new technologies, and therefore I was expecting closer to the middle of the leaderboard, but meaning even in the top 10%. But it looks like you need to do much more than just put the sentence encoder through a neural network to get results.
Yes, Steve showed
Yeah,
it before. Sorry, yeah, the example about Beethoven, the it was not able to distinguish whether it's asked about where he was born versus when he was born. So maybe it's not that good for this. I mean, when for Quora type question distinguishing, yeah, this kind of shows that USC is probably not that good for. I mean, when you're using it directly for this type of task.
that's what I was thinking as well. I was like thinking if instead I went to like just a pure word-based one as opposed to a sentence-based one, because yeah, these sentences, they are very similar, and so like it's not as if it's wrong or whatever. It's put its encoding vectors into sort of a similar area of hyperspace or whatever. But yeah, from our point of view, where we want to find sentences that are the same, basically, I think you need to look at like the sort of the question word, and like if you've got completely different question words like when and where, then you could say, okay, these sentences aren't going to be the same from our point of view of being duplicate questions. So yeah, perhaps it is better rather than having whole sentences and using the universal sentence encoder to maybe switch to using a word-based one.
Yeah.
Yeah, that's interesting because I didn't have time to do even this, what we discussed last time as very basic, take the words, kind of do a min max on them in for each of the two questions and then put them through a neural network and get train them and then figure out whether what that result is. And I'm just hopefully I'll have time this week to try that and see how it compares to this result. Um, Sorry, anybody else want to share what they were able to do this week on this task?
I have a quick question
Go ahead.
on the notebook. So when you're doing batching in the beginning, so do you like so the I guess the size like it's a pretty big data set. So do you train um you just create batches and train on everything? Is that
Yeah, so before I create the model, I take all the sentences and get their encoding vectors.
mm-hmm.
Um, and then just, yeah, so I've got like one encoding vector per question. And so, yeah, so I just stick those pairs in with the is duplicate parameter and just train on that, but just a standard binary classifier.
Mm-hmm.
Yeah, I think even in the base notebook that Gautam had, I forget, was it 128 or 64 batch size Gautam you had used? It's probably there in Steve,
Is it
your
for
notebook.
converting the sentence to the embedding? We did not really train, right? The batching I did was for converting the sentences to embeddings.
To
And I
to
used
use the sentence universal sentence encoding. That's to generate the embeddings. Yeah, right. You said
I think that was a batch size of 100,000 or something.
Yeah, it was 100,000. Yeah,
1024. Oh, okay.
no,
Oh,
it was
100,000.
100,000.
Okay. Yeah,
100,000 at the
yeah.
time. Yeah, because you've
Right,
got
right.
whatever it
Yeah.
is,
4 million or
400,000 or something.
yeah,
Yep.
400K or
And
something.
there are
Yeah.
no parameters as such, right? You are just converting a sentence to
Yeah.
its
You're right. You're
the
right.
dictionary lookup, basically. Nothing
Yeah.
else. Yeah.
Yeah. So in the case of the training that you did, Steve, then to your question, what was your batch size? 64 thereabouts, or
Yeah, it was 64 actually. Yeah.
okay?
Yeah, so it was just default, and I haven't played about with that at all. So,
And your model is basically this, dense layer concatenation, and then another.
yeah, so it's just like the way I had to put it, it's like actually got like sort of two inputs. So it's got like a dense layer per encoding vector, and then it concatenates those, and then there's a final dense layer, and yeah, just a sigmoid function to do a binary classification on it. But yeah, as I say, it was just like a really simple model, and it was more just to check how it would look. And yeah, like would it work okay with the automatic submission into Kaggle?
Mm-hmm.
Yeah.
So yeah, like the actual sort of the classifier or whatever, it's very basic, but sort of the rest of the sort of the structural bit, anybody could take that and automate their process now.
Cool.
Another
Yeah.
thing that people have done is just invert questions, and so it gives you more training data. And yeah, I mean, that won't give you a huge jump, but yeah,
What was that? Sorry, what do you do?
you can just invert the question 1 and question 2, so that just adds double the training data.
All right, cool. Yeah, I hadn't
Swap
thought
them, you
about
mean?
that. Yeah. Yep.
Yeah, swap it. Yeah.
Yeah. Okay.
Has anybody tried paraphrasing?
What do you mean by paraphrasing?
So you can actually like take some other like network, and they do paraphrasing. That's like a task you can you can restate the question so it's the same. I think paraphrasing is a task where you take a question and you generate another question that basically has the same meaning. So that will also sort of like I thought about it like inverting a string. Like I don't know if it changes the meaning or not, but it kind of doesn't have any meaning. But paraphrasing will actually give you a legitimate, extra legitimate training point.
I haven't tried it. Like as I say, I've just tried the simple things. So
You're suggesting taking a model that is already trained to do paraphrasing?
Oh no! I was thinking so I was gonna try to like use the sentence embedding, but I haven't had a chance to work on it yet. But one of the things that you can do with like one of the tasks you can do with sentence embedding, you can actually do paraphrasing. So in theory, that can like that can be like augmentation technique way for this, where you basically increase your training size.
So, Yuri, on that, are you saying use the universal sentence encoder to generate paraphrases?
I don't know if universal sentence encoder can do it, but the SBERT can. I don't know how well they do it, but that can that basically will, like, if increasing training size helps accuracy, then that might be interesting thing to try. So basically, just so you have a pair of questions, you can just apply paraphrasing to them, and then you get like 5 times number of training data.
So, anyone else try any other techniques? Want to share?
So I have been working on the architecture that we saw on the Quora page that you had shared, Srinivas.
Right, right. Couple of yeah.
Yeah,
They had two,
I'm
three different ideas, right? Yep.
yep. So I'm halfway there. Maybe I can share that.
Yeah, go ahead. That'd be
Okay.
great.
Can you see?
Yep.
Okay. So the one I'm trying to do is like any of these basically. Uh, so you have an LSTM here, and so you pass in the word embeddings. It could be GLOW or fast text or
Right.
whatever,
Right.
and then you take the hidden state at the last, the last hidden state of both questions, concatenate them, and have a dense layer, and then predict the probability of is duplicate.
So, sorry, Gautam. So
Yeah.
you take the embedding and then create. So, are you making the LSTM's size be the longest sentence or something, or how do you
Okay.
form?
So in LSTMs, you can have variable length as opposed to transformers, right? So each batch can have its own LSTM length. So PyTorch has this useful thing where it does batching by putting sentences of similar length together.
Right, right, right. In fact,
Yeah.
FastAI uses that. It puts sticks those together, and well, at the top or bottom doesn't matter. But yeah, you're right. It's kind of collects similar size sentences closer together.
Yeah.
Right.
Yeah. So I think PyTorch has done that for me. I'll show the code as well. Uh, so I've been using a library called TorchText. I've actually been like just looking into it in the past 3-4 days, and yeah, I'm just learning about it as well. So yeah, uh, so okay, I'll just go to the main stuff. So there is something called field. I don't know how many of you are familiar with TorchText. So in TorchText, you can create something called a field object. It's inside TorchText.data, and you're just saying how a column should be processed. So if it's a text, so TorchText is basically an easy way of uh, dealing with text data. It numericalizes, creates vocabulary, creates the vectors. All of that hard stuff is handled for you. So I'm just saying there is a column called question one. I mean, there is a field which I've named question one. It's sequential. So if it's text data, it's sequential. And if I want to create a vocab for that, I say vocab equal to true. How do I tokenize it? I can just give
Yes.
spacey. It will use spacey to tokenize. And if I want to make it lowercase, so these, the question one and question two would be treated in the same way. Then you have the target field, which is not a sequential, it's just 1 or 0, right? and you don't want a vocab for that.
Hmm.
And here I'm just saying what is the column name inside the CSV that I'll be loading. The column name is question 1, and for question 1 I will process it using this field. So the column
Okay.
question 1 would be processed using this field
Question
object.
one. Okay.
Yep. And question 2 for, and this is just a shorthand that you can use to refer to this field later on. Just a shortcut kind of thing. And is duplicate is this target field.
Target. Yeah.
So basically specifying which columns to use from the dataset and which field should be used to process each column.
Hmm.
That's it. And then so it has a very handy function called tabular dataset dot splits, where you can give what is your what is your test or validation file, what is the format it is, and it creates your train data and valid data. It basically applies these fields and processing and all of that, and it creates the train data and valid data for you. So one thing that I did prior to this was uh, I I read in the train .csv. I did some basic pre-processing, and then I saved it back. I split it into train and valid, and I saved it back to CSVs as train split and validation split.
Okay.
Because this particular function needs CSVs again. I'm not sure if it can directly take pandas data frames, so I did not do that. And I split it using Stratify. So since it's quite imbalanced, I wanted the train and valid to have the same ratio
Question.
as
Yeah.
it was. Yeah, same ratio as it was in the original dataset. So
Hmm.
I use that. And so if I just do train data, you can see the first example, you can see that it is already tokenized. This is the first question, this is the second question, and this is the is duplicate result.
Value.
Yep. And then uh, you can load in vectors as well. So I have my vectors in glove vectors inside my drive.
Hmm.
So it has this vocab.vectors thing. And so this build vocab is how it builds the vocabulary. So what I did here was I have separate vocabularies for question 1 and question 2. And I'm just saying that vectors, you can use this thing that I just created here. And another handy thing is you can just give it in strings. You can just write glove.6b.100d and it would download it for you, but that takes time. So I have it already downloaded. Yeah.
Downloaded.
So
Okay.
build vocab for question 1 and question 2. This is the max size of the vocab. And then you get your familiar train
Loaders.
data loader and
Are
bucket
they
iterator.splits. Yeah. Sorry.
or build vocab actually builds embeddings or creates embedding for question 1 and question
No,
2?
it builds the vocabs actually. It does not. So the reason why you give embeddings here is not to build your embedding. What it does is, wait, let me think about this. Okay, what it actually does is it ensures that the order is the same as it's in the glove embeddings. So in my glove embeddings, if the first word is aardvark, then in my vocab, if I have the word aardvark, I would ensure that its numerical number is 1. It's just for ensuring that order, it's just to ensure that the order in the glove embeddings and the vocab that you are making is the same. I don't think it's actually creating the embeddings in this step. That comes later on when you, that comes later on.
Okay.
Does that make sense?
Yeah.
Yeah, it's just to ensure that the order is the same, so that later on when you uh, later on what you feed into the model is just numbers, and it has to, and obviously when you input a number 3, that same word has to be there at the third position in my glove embeddings.
So it
that's what it is.
maps the question words into the same uh, dictionary or the same um mapping as the glove embedding
Yes.
words,
Yep.
right?
Yep. So
Okay.
so suppose the word greatest in this question, suppose the word greatest occurs at position 500 in my glove embeddings file. Even in my vocab it would be at 500. Even in the vocab
Yeah.
I build it would be that's why
Yeah.
it's embedding. So
It's the position of the position in a vocab, or is it the token number? The
it's the
example you
same thing,
gave
right?
for, sorry?
That's the same thing, right? So each word has an associated number in the vocab, and it is
Yeah.
these numbers that I'll be feeding to the model.
Correct.
Yeah.
It's the index into your glove embeddings, right? It's like the index into the embedding table.
Yep.
Yeah, so the only thing which I was thinking, your vocab for a question one is going to be very small,
Mm-hmm.
and then the glove embedding is like a whole corpus, whatever they trained on. So
Yeah.
so the position, okay, okay, in a sense, then what we are saying is the token number or the indexing of those words in a question one will have a same numerical number which is in a glove embedding.
Yeah,
Yeah.
it's doing a little bit more based on what you just mentioned to Dinesh, because from what you said, if the since from Gautam notebook, it seems like you can specify the vocab size, and if the vocab size is 20,000, whereas glove has, I'm just going to pick a number, 60,000, then it will only take 20,000. So it will still make sure that the 20,000 have the same, the index number.
Yeah.
It will have to adjust to make it the same as for the glove embedding. That is, the word will get the correct embedding, but the index to the word may change from the glove embedding to what it is for this. But that prompts a
I think the
question,
index
Gautam,
would still be the same. So it won't throw anything away from
at the
the
glove
original.
embeddings.
Yeah.
Right. But it will pick, but there might be, gaps in the index, but that doesn't matter.
Yeah.
But one
That doesn't
question
matter.
I
Yeah.
had then is, you would probably need to keep the max size the same, right? Because if you varied the max size between the two things you had there, then that could lead to some problems, right? Or I haven't thought whether you can
The
change
max
the
size of
max
the
size.
vocab.
Yeah.
Mm,
Right, because if one
Uh,
is 10 and the other is 20, then you may not find all the words, right? I mean, they may be large enough to get everything, then it doesn't matter. But
yeah.
if it is,
Yeah.
anyway,
Unknown
something to
words
play
would
with, I don't know.
still be there, right? Yeah. I'm not sure how it would be handled, but yeah, unknown words could still occur.
Yeah, yeah. Anyway.
Yeah. Then you get the PyTorch data loaders. I gave a batch size of 32, and that's basically all I did. I mean, I haven't proceeded after that. So this one is I've just started building the model. Uh, so there would be two embedding layers, and then each has its own LSTM. Um, yeah, each has its own LSTM, and then I would take the output from this LSTM and the output from, okay, this would be two output from the last hidden state of both of these LSTM, and then I would concatenate them, and then a fully connected layer. So the final shape after the concatenation would be 2 into hidden size. So I wanted a linear
Right.
layer 2 into hidden size to hidden dimension, and then hidden dimension to 1, which is the final output. Yeah, and I have not proceeded after that.
Interesting.
Yep, that's all I have.
But by the way, I don't know if you've seen. I think we've seen this technique. At least I've seen it recently. How to deal with unknown words with glove embedding, and I think it would work in case like this. I think what they do is they basically assign a random vector to an unknown word, and the way it works is like, because it's in this giant space, it's not close to anything else. But if you see that word second time, then you already have a vector for it. So if both questions have that unknown word, you will basically, it will have the same vector.
Yeah, but the tricky thing is what would be the number for that word, and how
Random.
to implement it. That, no, I'm not talking about the I'm talking about the number that you input to the model.
You can basically, I think you just basically like add extra. You just decide like you're gonna like add those at the end. So you like first time you see it, you generate embedding and you add it to your dictionary, sort of.
Okay, yeah, that's tricky to implement. Yeah, you
Um,
would.
Sorry, question, Gautam. So you're taking the glove embeddings and putting them through another embedding layer. Is that right?
No. So the for this nn.embedding, there is something called weights matrix, right? I would just assign my glove embeddings to this embedding. I'm not sure exactly the syntax for that. So
So you're not. So you're just. If you go back to that picture that you were, yeah, this one. So you're just creating the representation one by just using the LSTM. So no additional embedding. The embedding one is the glove embedding.
yes. Yep.
Okay. Okay. So rep one is just the output of the hidden layer after it has gone through, after all the words have gone through the LSTM.
Yes.
Okay.
The output of RNN1 is rep1, output of RNN2 is rep2, and then I would concatenate them,
Right.
and then the
Yeah.
two fully connected layers.
Right. Yeah. Okay.
But that embedding will train, like.
Yeah, I guess you can make it trainable.
Okay.
But you may not want to, right?
Yeah, I'm not sure about that.
Because then you would be back. I mean, you would be tweaking the glove embeddings if you allow them to be trained.
Yeah, yeah. I don't know if that's a bad thing or a good thing.
I thought, at least my recollection, I could be completely wrong, but it'd be good to check. But I thought that I saw that generally not a good idea, because the problem is that some words will get shifted and some won't. And that worsens the thing, rather than, I mean, of course, you could always try it both ways and see for yourself, but my recollection from either Jamie's lecture or somewhere is, when you allow it to backpropagate, then what happens is that for the words which are seen, they get shifted, and the words that aren't don't. So the relationship between words which glove embedding has is becomes, for lack of a better word, not helpful. It screws with the um, things which are similar no longer are similar, and things like that. So I thought I saw that it's better not to backpropagate into the embeddings. but
Okay.
I could be wrong.
Yeah,
Cool.
that's all I had. Yep.
That's be great to see the results of that approach.
Yep.
Yeah,
I'll share this once I'm done with it. Yep.
yeah, that'd be cool. Okay. Anybody else have any other things they wanted to share, or things they've tried or hope to try?
No, I didn't have a chance to work on this, but I posted a link to. It's like a general sort of Microsoft statement on how to do deep learning with Azure, and
Mm-hmm.
and they have a page on sentence similarity, which actually like it was done more than a year ago, but it has I think I really like they have a bunch of baselines, so I think that page is good for that. But they use universal sentence embedding also, and they have several other networks.
Cool. Yeah, I haven't had chance. I saw your post, but yeah, look at it. Thanks. Anyone else? If not, the one additional thing. Sorry, Mani, were you going to say something?
Yeah, I just wanted to ask a question because this is the first time I'm joining this. So this seems very similar to the image similarity thing that in the tutorial, like fast AI tutorial, where in the advanced section there is a Siamese network to find out whether two images are similar. But I haven't seen anybody tried.
Oh, there are quite a number of. In fact, that's a little bit more advanced, but yeah, I mean, in fact, I can share. There are papers on using Siamese networks for text similarity or question similarity as well, Money. And there, we are trying. I think just wanted to try simple approaches before we got to that, but there is specific paper and approaches of using Siamese network for this task as well.
Okay, makes sense. Makes sense. Thank you. Okay.
Yeah. I mean, I think I posted earlier as well, and I'll repost. But we're just kind of working our way through some simple techniques to see what we can get, and then as we continue to probably get poor or not that great scores, we'll have to get more and more aggressive in what we're trying to do, and we'll have to get there, I think.
Yeah, that makes sense. Okay, thank you.
So what I wanted to share was something that I shared at the um, again, I think the approaches that Steve and Gautam have shared are, and even I want to take the simple min max and try where it lands. Gautam is trying a more advanced approach, and Steve might have even better results than what he has by next week. But I just wanted even to try the min max of the words, as you were saying. That's kind of trying to see whether it gives a baseline. But towards the end of last week, I'd shared something, and I just wanted to kind of share that again. It's a little bit even more aggressive approach than what Gautam has attempted to do, and it seemed to be state of the art, or at least a few years back. But let me share, see whether I can get to my no, I think it's this guy. Okay. Um, okay, can you folks see my screen. Can you see my screen on which is my thoughts on skip vectors?
Yes.
Okay, so this skip thought vectors idea is something that is probably just a little more advanced than what we've discussed so far. And since I just mentioned it last week, I just wanted to spend maybe the last 8-10 minutes pointing to it and discussing at least my understanding. I'd encourage people to read it and see. There's a paper related to it. I think last week I posted the links. I'll highlight it or point to it. But the point generally is, again, to generate. You can think of skip thought vectors as almost generating what the universal sentence encoder is generating, except that the thing I like about it is that you could probably, at least the approach seems to suggest, if implemented, that you could customize. It's like developing a customized sentence encoder for just the data of the Quora question pairs. Why do I say that? Because what the structure of the skip thought networks is this encoder decoder context, and each of the encoder as well as the previous decoder and the next decoder are all GRUs or LSTMs, and you take sentences, which in this case would be the questions that we get, let's say, and we could just stack the first questions as well as second questions and generate kind of the equivalent of what the universal sentence encoder generates, which is an encoding for per sentence. So this would be an encoding per question. And then the way the skip thought vectors work is, initially this network is trained by using an encoder, a previous decoder, and a next decoder. And what each of these does, I'll get to in a minute. And after the training is done, you discard the previous decoder and next decoder and just use the embeddings that are generated by this encoder when you're actually deploying the skip thoughts, for example, for our task. And it's kind of fascinating as to how this works. So, for example, the encoder network, what it does is it takes the sentence. In our case, you can just think of it as the question at the index I. So, whatever number of questions you have, you just stick them in a list, if you will, and it generates, and this part is similar to what Gautam is trying to do, generates a fixed length representation, right, of the sentence. Now, what the previous decoder, which is again an LSTM, what it tries to do is it takes this embedding that the encoder generates and it tries to predict each of these words in the sentence prior to the current sentence. And if you think about it, that's pretty crazy. But we'll get to how it's trained and what enables it to do that. But essentially, the previous decoder is an LSTM that takes this encoder output ZI and tries to generate the sentence, the prior sentence, or that is the prior question to this question. Okay. And then the next decoder just tries to generate the next question from the previous question. Now, you could say, how in the world is it able to even do that, or what do you do for training? So the training is done in a kind of self-supervised way, in the sense that the decoders are trained, as it highlights here, to minimize the reconstruction error of the previous and the next sentences, given the embedding ZI. So what that means is, you stick the whole network together and you feed in these sentences, and obviously this thing will screw up in predicting the prior or the words of the prior question, and that error is back propagated to the encoder, and this will obviously fail to predict the subsequent sentence words, and that's back propagated into the encoder. And that's how the encoder's output is better trained to represent the semantics of XI, such that it helps the previous and next decoders to do a better job of predicting the prior and the next sentence. Now, as the guy explains, it's kind of crazy that, so the end product of skip thoughts is the encoder, and the decoders are thrown away after the training. And then the trained encoder is used to generate a fixed length representation of sentences, which can then be used for downstream tasks. So you can think of the encoder basically as as building the universal sentence encoder equivalent. And it eventually, a good encoder, if you're able to build it, would then mean that the representations of semantically similar sentences are closer. But as he goes on to explain, how the hell does the decoder know to predict something about the prior questions or the words in the prior questions? And the way that is done is by teacher forcing, which basically means that you give word by word the prior. During training, you provide the decoders with word by word while being fed the words of the true target sentence from the corpus with a delay of 1 time step. So it's like this, right? And so in effect, the prediction, and this is the key element here, is a probability distribution over words that could occur at that position, given obviously the context, which is ZI of a neighboring sentence, and of course the words in this, that is the previous or the next sentence, but words that have occurred only before the current position. So what we essentially are doing during training is doing teacher forcing for the previous and the next decoder by providing these words only as far as the step that they have seen, conditioned on what the encoder provides. Okay, and that is what, in summary, the skip thought vectors does. And he kind of goes on to discuss some of the, why do we do 100% teacher forcing. And it's fascinating to me, this particular approach, because it kind of seems very similar, or at least rudimentarily similar, to what BERT tries to do, which is predict some words, that it doesn't know about. Of course, there's no masking and other stuff involved because it's not a bidirectional thing. But he also goes on to discuss, hey, I don't know why the guys who did the skip thought vectors didn't implement bidirectional in LSTMs in these decoders as well. So, if you want to really be aggressive and creative, you could probably try implementing bi-LSTMs for these guys as well. The paper, I think, only refers to forward RNNs or LSTMs. And so he goes on to discuss that. And finally, the encoder learns to Yes, go ahead.
I have a question. So don't the sentences have to be like contiguous sentences from a paragraph?
No, that's the fascinating thing, right? No, these sentences don't have any kind of necessary relationship to each other.
But like the sentences seem like they are continuous sentences. The elephant was still, it was taking a nap. It looks like they are continuous
Yeah, they
sentences.
could be. That could be. But on the other hand, that I don't know whether it is necessary aspect of training this and whether we could train it with just the questions list. That is what I am wondering, or whether the training of the encoder would need to be done with like a Wikipedia or book corpus. Maybe you're right that the training of the skip thought vectors would need to be done with uh, like a book or a Wikipedia text corpus where the sentences have some relationship to each other.
So the encoder just takes the single sentence as input, right? Not, it's not
Yes, one at a
okay.
time.
Okay. Yeah. Yeah, I don't, it doesn't make intuitive sense if they are completely different sentences.
Yeah, I was kind of, even with the paragraph thing, I was quite um, impressed or surprised that the decoder is able to do what it does. But then the reason it struck me as not being too far fetched is because if you think about it, you can begin to see and this paper, this is not a, there's obviously an explanation of the paper. There is the paper and the GitHub code for it for skip thought vectors is, I think, 2015 or 16. So it's about 3-4 years, which is eons in NLP these days, right? So you can be the thing that was also interesting to me was you can begin to see things like where the BERT guys got ideas of predicting individual words or masking them and then sticking by LSTMs versus just LSTMs or RNNs in each of this. And BERT also does a variant of this, right? Because it predicts whether the next sentence is a appropriate sentence or not, for example. So I just thought, and some of the highest scores in the task of sentence similarity or question similarity have been previously. I don't want to get to state of the art currently. We'll do that towards, after several of us have taken crack with different methods. But it seems several years back, the state of the art was achieved using skip thought vectors. So I essentially, I mean, at an abstract level, and I don't know what you think, Gautam, since you played with Universal Sentence Encoder the most, I'd be interested in your take. But it just seemed to me a way of building what is an earlier version of the Universal Sentence Encoder. Because
Yes,
the
yep.
ZI would be what your embedding of the sentence encoder would be providing. So I thought this is like a poor man's sentence encoder, if you will.
Yeah. Yeah. But yeah, and I wouldn't be too hopeful of getting great results either, because you would have I mean, it wouldn't depend on the data set that we have, right? You would just have the output from encoder. I mean, and it's exactly similar to USC.
USC,
Yeah.
right, right. But that's where the thing I was thinking, and is, would it make a difference if we train the USC with just the sentences that we have in question? And that brings another interesting twist that you highlighted, which now I'm also thinking, what would happen if we provided, question pairs as the sequences as it went through?
Yeah, I'm not sure it works that way, but yeah.
Yeah, no, I mean, yes, I agree with your statement. It's not likely to give very high scores. But given previously it has yielded, 3-4 years back, some state-of-the-art result, I was just interested or intrigued in generating and then providing the questions.
I was saying like to me it seems that they are part of the same paragraph, like continuous sentences.
Yes, you're right. It definitely looks that way, that they are paragraph oriented. But I thought this was an interesting or a fascinating, and it seems it's one of the approaches to. By the way, it's also been used to Yuri's point, if I recall correctly. My reading says the skip thought vectors were also used to generate this paraphrasing of sentences. I believe, I could be wrong, but that's my recollection. And so that's another kind of approach of trying that could be tried beyond. But Gautam's point, it may or may not. In fact, I would think that the universal sentence encoder would probably use even more advanced techniques than what this method tried, because it's dated and it doesn't use attention or any of those kind of modern concepts. But I just thought fascinating in between thing that seems to explain how the universe, or as I said, a poor man's universal sentence encoder. Okay, anything else?
Actually, I have a question, I guess more for Gautam. What's the best resource to understand universal sentence encoder? Should I read the paper? Or is there like a good?
I have not understood universal sentence encoder actually. Yeah, I mean I've just been using them as a source for sentence embeddings. That's
Okay.
all. I have not learnt about it or anything.
Okay. All right. So I actually did a quick experiment on Beethoven, because I was curious how sentence embedding would work with when and where, and it's SBERT is not differentiating them really well. I was hoping it would work, but it didn't.
But how do you quantify whether it's differentiating or not? Like,
Just cosine similarity.
and then where do you draw the line? It's similar.
Oh
Or,
no, it was like
because they are similar in some aspects. Uh,
Yeah, they're
where was he
mostly
born?
similar.
Yeah, so it's difficult to just. I mean, you may not be able to just throw away something because it's told that they are similar, because they are similar in some aspects, right? So it's difficult to quantify these things.
Yeah, in fact, I think that's, as we discussed a couple of weeks back, that's the problem why the cosine similarity doesn't seem to be able to distinguish, right? Because there is so much overlap between things which are whatever, not the same question versus the same question, the zeros and the ones, and the cosines overlap so much. So I think, as Steve was saying, there is just one word, when and where, and everything else overlaps. And on that one, though, there is, because of that, it switches between a target of 1 and a target of 0, because of that one word difference, when and where. Whereas the cosine similarity will probably be very high for these two sentences.
So did you guys see my notebook?
Yep.
Okay.
Yep.
So I just added not, and that changed the similarity, but again, not as much as I hope it would.
Yeah, I was wondering, because of the fact that universal sentence encoder, if it's taking all the words, and forming like its like encoding vector for them. Obviously, those two sentences you would think they would be sort of very close together in their parameter space, and would have a very close cosine similarity. But yeah, so I was thinking of doing like a sort of pre-processing stage. Obviously, on the question words like when and where, you would think you could sort of just pre-process all the questions. And if they have one question begins with when and one begins with where, you would automatically be able to say that they're not the same question. So you'd be able to sort of eliminate it that way. But that's why I was wondering about the universal sentence encoder. Is it maybe sort of too, because of the fact it sort of just gives you one encoding for the entire sentence, whereas if you were to take it on separate words, then it might be better.
Yeah, this one is S-BERT. This one is this one. But yeah, I actually like I was trying to do similar things, not for this, but for something else. I was trying to see like before I learned of this trick with random embeddings. I was trying to see if I can combine embeddings for known words with a sort of like word count for unknown words, and there was like no easy way to do it, but I guess there is one. You can kind of combine two scores, like you can like just count number of whens and wheres, and then combine that with a score from or count meaning 0, 1. But yeah, I didn't come up with any good like cost function between the word being there and the rest of the sentence, embedding the rest of the sentence.
So to your point, Steve, so would you have a vocab of words which kind
Yeah,
of
I thought about having
point to
a
question?
vocabulary of question words. It's like obviously there's only, I don't know, 10 or 20 words which are question words. And so if your sentence begins with any of them and the second sentence begins with a different one, then they're probably different questions. And so yeah, like I thought of having like a small vocab of words and train like a really basic network to sort of recognize just those 10 or 20 words and their presence in the words that sort of are duplicates, to sort of find out which words exclude each other, and have that as a pre-process stage to exclude sentences, and then have a more advanced network with the sentences that are left behind.
Fascinating. Yeah, that'd be kind of cool to see what that does. Interesting.
I didn't understand that. So are you saying if one sentence starts with a Y and the other sentence starts with how, they are different? Is that what you're implying?
Why and how they might be the same. So
okay,
yeah, so you would have, as I say, like a small vocabulary of your 20 question words, and you would train your network to see which words would go together. So like why and how they might go together, whereas like when and where they wouldn't go together. So if one question began with when and the other one began with where, you could automatically exclude those and say they're not duplicates. So by excluding sort of question words that don't go together, you might be able to like get rid of like a whole lot of the questions immediately.
yep, interesting. Yeah.
Do they have questions where when is not or where is not in the beginning of the sentence? Or most of the time it is?
I'm not sure. That's why I would have to sort of put it into like a network or whatever and train it to see.
I know,
I'm not sure.
Like a spacey part of speech might be able to just tell you whether that's when and where is actually, I don't know what the right word is, like part of like a question mark or not. Because Spacey does pre-processing and it like tags all the words in the sentence.
Yeah. Yeah, I haven't tried it yet, but it was just like an idea I thought sort of would be a quick way to sort of establish if things aren't duplicates.
Yeah, that would eliminate a bunch, and then you can worry about the remainder and stuff. Yeah, that'd be a fascinating idea to implement. Cool. Okay. Already 20 after. Anyone else have any last minute things they want to share? If not, thanks Gautam and Steve and Yuri and anyone else with inputs. Thanks everybody, and I'll post the recording shortly, and hopefully we all make progress by next week as well and try to better our scores. Now Steve is set, I think the bar is at 0.39, is it, Steve?
It is, yeah. So it's not a very high bar yet.
Well, it's higher than any of us have reached so far. So let's aim to pass that bar next week. Cool. Thanks, everyone.